and the phasor. Can somebody tell me the difference? So let's say no, meron akong phasor A, which is equal to A plus JB, and then meron akong complex number na A, which is equal to A plus JB. Ano yung difference nitong dalawa? Anyone? Can I call you out in turn? Isa-isas. Ivan, can you answer me?
Hello, sir.
Yes, sir.
Uh, yung una po, sir, para siyang like vector siya, tapos yung pangalawa po is parang coordinate lang siya.
Not exactly. No, not exactly. Anybody else? Si Aquino, do you know the difference between the two?
Yung pagkakalala ko po is yung phasor gumagalaw po siya in the plane. Tas nag-form po siya into sinusoidal. Tapos yung complex number po is ano lang, steady.
Okay. Actually, tama yung sinasabi mo, no? Yung phasor rotates in the counterclockwise direction. At angular velocity omega. Okay. So kung ito yung complex plane ko, okay, ito yung real part, ito yung imaginary part. Kung ito yung phasor ko, no? Let's say this is my phasor A, ito umiikot ganyan at angular velocity omega. So this is a phasor. Samantalang yung complex number, okay, yan lang siya, A, no? Okay, pag minsan we say we do that also, no? But that's A, no? So ito, this is a real part. This is also an imaginary part. Ganun din dito, no? This is a real part. And then this also has an imaginary part. Pero ito, umiikot. Umiikot siya. Ito, pirmi lang siya dyan. Hindi siya gumagalaw. So pag tinignan natin yung real part, ito, no? Imagine nyo, ito umiikot. Yung real component niya, nag-uumpisa dito, okay? It will be going this way, no? The real component will be going this way. And the imaginary component will be going this way. Samantalang ito, this is fixed. Okay? That's very important. Kaya yung sa notation, kung phasor siya, linalagyan natin ng arrow or sinasabi nating ace of j omega. So this is a phasor. Pag pinakita na natin ganyan, this is just a complex number. Okay? Is that clear? Because that's an important concept, no? You have to know the difference between a phasor and a complex number. Ivan, malinaw na ba yun?
Yes, sir. Okay na.
Okay. Okay. And then we took up phasor transformation. Kinuha natin phasor transformation. So let's say I have a function I of t. Let's say this is equal to I of m cosine of omega t plus alpha. Ano yung phasor nito? Si Mori, do you know the answer? Nawala yung isa sa inyo, no? Tatatlo na lang kayo ngayon. Mori, can you hear me? Or are you there?
Yes, sir. Sorry.
No. Do you know the answer? I don't. It's okay if you don't, no? Kasi like I said, baka hindi pa kayo up to speed dahil sa exam. But how do you convert this to a phasor, yung I's of M?
So, kukunin po muna yung RMS value ng current. So, magiging IM over square root of 2.
Okay, so the phasor I is IM over the square root of 2.
Tapos yung angle po niya is yung alpha. Alpha po ba yan?
Yeah, alpha.
Ayun.
Okay, that's how you convert this to a phasor. Ano ang okay? What actually happens when you convert this to a phasor, no? What actually happens when I convert this to a phasor? Ang nangyayari is, una kukunin ko to. So that's Im cosine omega t plus alpha. Kukunin ko yan. Dadagdagan ko ng imaginary component. So that's J Im sine omega t plus alpha. Okay. And then I divided by the square root of 2. This is actually equal to I. Because if I converted this to its real and imaginary component, the real component of this phasor is this, no? Im cosine omega t plus alpha divided by the square root of 2. And the imaginary component of this phasor is this. Jim sine omega t plus alpha divided by the square root of 2. Kaya may omega t tayo because it is rotating. No? As opposed to it being just a complex number, walang omega t, no? Alpha lang yan. But because it's rotating, may omega t. So, anong nangyari, nung kinonvert ko itong time domain expression, we call this the time domain expression. When I converted it to a phasor, I actually added an imaginary component. Okay? That is how I make it a phasor. Itong phasor ngayon na to, the phasor will be used to compute for other voltages and currents in your circuit. So ang mangyayari, yung mga voltages and currents na yon, since meron tayong imaginary component dito, yung mga makukompute natin ng mga voltages and currents, meron ding magiging imaginary component. Now what we do in the reverse transformation, you disregard the imaginary component. So kung meron akong, again, no, kung meron akong, let's say V is equal to V of X at an angle beta, ano yung reverse transformation nito? Can somebody tell me? What is the reverse transformation?
V of t is equals to square root of 2 Vx cos omega t plus beta.
Yeah, V square root of 2 Vx cosine of omega t plus beta. No? So anong nangyari? In effect, yung imaginary component nito, tinanggal ko. Iniwan ko na lang yung real component. And then, because I divided here by the square root of 2, i-multiply ko ngayon by the square root of 2. Okay, kapag tinignan nyo yung notes nyo, if you take a look at your notes, I think it's either 10A or 10B, no? I can't remember. Yung unang phasor transformation niya, wala nitong square root of 2. Did you notice that? Nakita ba nyo yun? Or hindi pa nyo nakikita yung notes? No? But if you take a look at the notes, the first transformation that was shown did not have the square root of 2. But later on, it was introduced. And why was it introduced? Because what we want to do here is we want to work with dito. We want to work with RMS values. That is why we put the square root of 2. But when we convert back to the time domain, we have to multiply by the square root of 2 because we have to go back to the amplitude. Ang form nito is amplitude multiplied by the sinusoid. Okay, so that is the history behind phasor transformation. When you transform to a phasor, you add an imaginary component, but when you transform back to the time domain, you remove the imaginary component because the imaginary component of your response is because you introduced an imaginary component to your sources. So tatanggalin mo lang siya para makuha mo yung totoong response. Okay, and then we took up impedance. Ivan, do you remember the definition of impedance? Again, it's okay if you don't, no? Because medyo...
Hindi ko na mo maalala, sir.
Yeah. Okay, if I have a component here, a linear component, or even a linear circuit, passive, a linear passive circuit. If this is my phasor voltage and this is my phasor current, the ratio of, the magnitude. The ratio of V over I is Z, and that is called my impedance. Okay. So again, this is a linear passive circuit. I have a phasor voltage across it, a phasor current flowing through it. The ratio of V over I is called my impedance. V is equal to I times Z. No? This is similar to Ohm's law. I'll put it in quotes, no? Ohm's law. Although in quotes, kasi hindi yan yung tunay na Ohm's law. Yung tunay na Ohm's law is with resistance, hindi with impedance. And impedance in general has a real part and an imaginary part. Okay, and then last week I showed you, no, that if I got the impedance of a resistor, let me call that Z's of R, that is just equal to the resistance value. If I get the impedance of an inductor, Z's of L, you remember what is the impedance of an inductor? Anyone? Naalala? Anyone?
Negative J omega I over omega C. Ay, L pala. JWL.
J omega L. That's right. This is J omega L. That's the impedance of an inductor. And the impedance of a capacitor, ito yung sinasabi mo, no? Z's of C, this is negative J over omega C. So yun yung impedance. So we said, okay, how do you analyze circuits now in the frequency domain? No? Frequency domain analysis. Okay, so step one, you transform the circuit. Transform the circuit. No? Your sources, your sinusoidal sources, you transform this to phasors. Okay, your passive elements, you transform this to impedances. Okay, then step two, you solve for the desired quantities as phasors. And then step three, you convert back to time domain. This is if necessary, no? If necessary. Because later on, I'm going to tell you that sometimes it's not even necessary to convert back to time domain. So ito yung mga steps, no? And then I gave an example, no? Here, you remember this example? So this is my circuit. I have a sinusoidal voltage source and then an 8 ohms in series with a 6.6 Henry inductance, and I want to solve for the current in time domain, the steady state, no? Steady state current in time domain, and the steady state voltage across your inductance in time domain. Okay? So find I's of t and V's of L at steady state. Actually, pag hindi sinabing at steady state, implied na yun, no? That is a steady state. So ano yung step one? Step one is to transform the circuit. So kita natin dito, omega is equal to 10. Yung 10, no? And then yung source natin is 100 over the square root of 2 at an angle 0. So we got 100 divided by square root of 2 because we want to work with effective values. Tapos walang phase angle, no? It's just cosine 10t. So yung phase angle natin, alpha, is equal to 0. And then Z's of R is just equal to 8 ohms. And Z's of L is J omega L. So that's J times 10 times 0.6. So that's J 6 ohms. No? Sa EE, by convention, lagi nating inuuna yung J. No? Hindi kagaya sa math that you say, in math you say 6I. Sa EE, for some reason, inuuna nila yung J. So they say J6. So this is now my transform network. Imbis na I's of t ang dadaan dito na would be my phasor I. Kasi phasor na itong source ko. So yung current ko dito magiging phasor. Yung voltage across the resistor will also be a phasor. And the voltage across my inductor will also be a phasor. So the next step is to solve for the required circuit quantities in the frequency domain. So this is now your frequency domain equivalent, or your phasor equivalent. So in the frequency domain. So ito yung circuit ko. KVL. So KVL applies here. No? KVL around this loop. You have V is equal to VR plus V's of L. But what is VR? No? VR is just equal to I times Z's of R. No? And VL is equal to I times Z's of L. So ito yung sinasabi kong parang Ohm's law. Okay? If you know the current and you know the impedance, then it's like just applying Ohm's law. Hindi kagaya nung time domain na if you were to get a relationship between V and I in the time domain, it's V is equal to L di dt. It's a differential equation. You have to do you have to get the derivative. Okay, so this is I times JR. This is I times Z's of L. You factor out I. So this is I8 plus J6. So solving for I, you just, 100 over the square root of 2 at an angle 0 divided by 8 plus J6. And you get this. Okay, may tanong ako sa inyo, no? Are you adept at doing this with your calculator?
Yes po.
Nagawa na nyo yan with your calculator?
Yes.
Si Ivan at saka si Mori, have you done that with your calculator?
Yes, sir.
So walang problema.
Sa internet po ginagamit ko, sir.
Wala ka bang scientific na calculator?
Wala, bibili pa lang po, sir. Pagka face-to-face.
Yeah. I suggest, no, of course, medyo kung medyo kulang ka sa budget, no, then it's okay to use the internet, no? But if you have a scientific calculator, it's very, very convenient to make these calculations, no? But I'd understand, no, kung medyo gipit, no? So if I know I, how do I get Z's of L? No? Ito na yun, no? I times Z's of L is equal to, if I know I, how do I get V's of L? So V's of L is I times Z's of L. No? So ito yung V's of L. Okay. Ngayon, pag minsan, interesado lang tayo sa RMS value ng I or RMS value ng V's of L. No? That already tells us a lot. In fact, in real life, when you encounter problems in real life, like in industry, medyo madalang nahihingin sa iyo yung phase angle, no? More often than not, ang interest would just be the RMS value, no? Although sometimes hinihingi din yung phase angle, no? But more often than not, itong RMS value lang talaga ang value of interest. So kung yun lang yung value of interest, andito na yung solution natin, no? Okay. But if we had to convert back to the time domain, then you do your reverse transformation. So this one, you multiply by the square root of 2, that's 10. And then ito ang phase angle mo. So cosine 10t, ito yung omega natin. Hindi nagbabago yung omega, no? So cosine 10t minus 36.87, and then yung v, okay, it becomes 60 cosine 10t plus 53.13 degrees. So that's frequency domain analysis. And ang kagandahan nito, since we're using just Ohm's law, no, if you convert all circuit elements into their impedances, no, parang you can treat it, or you can use all the techniques that you learned for resistive circuits. No? So you can do network simplification, you can do voltage divider, current divider. Ito nakalimutan kong banggitin last time. No? You can do source conversion, node and mesh analysis, superposition, Thevenin's and Norton's theorem. Okay, and then impedances in series. I introduced this. No? Z equivalent is just the sum of all impedances. Impedances in parallel. Z equivalent is just the reciprocal of the sum of all admittances. Admittance is the reciprocal of impedance. When you have two impedances, it's just product over the sum. So parang resistive networks lang. And then ito yung Y to delta and delta to Y, where I gave you these formulas. This is to simplify circuits where you cannot find elements in parallel or in series. Then you can do Y to delta and delta to Y. So, and we did this exercise. We did this exercise. So let's, just as a review, let's do this exercise again. Ano ang value ng Z's of L dito? Can somebody tell me? Ano yung Z's of L? Ano yung impedance nito? May calculator ba kayong katabi dyan? Anyone?
Sir, J 7.54 ohms.
J 7.54 ohms. Let me check my notes. Yeah, that's right. No? This is J 7.54 ohms. Okay, yung iba naman, anong value nito? Anong value ng impedance nito? Anyone? Para mahasa kayo, walang calculator nga pala si Ivan, no? Si Mori, what is the value of this impedance? Are you attempting?
Negative J over 0.27. Wait lang. Tama ba?
Negative J over
0.27. So, ay, tama ba? Ay, negative 0.27 J.
No, omega is 377, huh?
Wait lang, mali ata ako.
So it's minus J, ito, this is, okay, minus J over omega C, no? So it's minus J over 377 multiplied by 10 to the minus 3.
0.27, negative 0.27 J nga.
10 times 10 to the minus 3, sorry. 10 times 10 to the minus 3. So ano yan?
Negative 0.27 J.
Yeah.
J.
It's minus J times 0.27 ohms. Okay? So, tawagin ko tong ZX. Okay? This is 55 in parallel with J 7.54. No? So this is product 55 times J 7.54 over 55 plus J 7.54. Okay. Anyway, my point is this, no? Kailangan practicing niyo yung calculator ninyo, no? You have to practice your calculator skills. Okay. If you compute for this is going to be
7.46.
7.47 at an angle. Sige,
82.05.
No, well, I got 82.19.
Ay,
Yeah.
7.54. Ay, 55 pala. Kala ko, 54.
Okay.
Mali ako.
No, but that's okay. No? Tapos ito naman, ito yung, let me call this ZY. So naka-series lang itong dalawang to. So this is the 20, let me call this ZY. That's 20 minus J 0.27 ohms. No? Of course, this is ohms. Okay? So ang circuit ko ngayon, meron akong 25 ohms. Meron akong ZX, ZY. Tapos meron akong ZX. Okay? So ZAB is just 25 in parallel with ZY plus ZX. Okay, I'll just give you the answer. No? If you compute for this will come out 11.915 at an angle 9.940 degrees ohms, which is equal to 11.736 plus J 2.057 ohms. So that's going to be the answer. So ano yan? That's just network simplification.
Sir, it's either complex number po ba or phasor? Pwede po yung, or phasor po yung mas accepted na sagot. Phasor form.
First of all, hindi ito phasor, ha? This is
Ayaw
not
nga pa. Yung form. Yung form. Phasor form.
You're talking about polar form or rectangular form. Yun ba yung question mo?
Wow.
Okay. This is polar form. And this is rectangular form. But Z is not a phasor. Ang phasor natin are voltages and currents, typically voltages and currents. Ang impedances natin are not phasors, they're just complex numbers. Okay? Okay, so ito, actually madali lang to eh. Ito using voltage division. So parehong problem to, no? This is the same problem as yung example ko earlier. Right? Ano yung transform circuit ko rito? My transform circuit, this is now V. This is 8 ohms. Okay? And this is J6, no? J6 ohms. J omega L. Omega is 10. Remember, omega is 10. So J omega L. So using voltage division, what is V of L? V of L is just V multiplied by J6 over 8 plus J6. So this is going to be what? V is 100 over the square root of 2 at an angle 0 degrees multiplied by J6 over 8 plus J6. Okay, I'll just give you the answer. No, this is 30 times the square root of 2 at an angle 53.13 degrees. Don't forget the volts. So ito yung kailangan nyo i-practice, no? Ito, isang pindutan lang yan sa calculator ninyo, no? So yun yung disadvantage even sa, ewan ko kung yung tool na ginagamit mo sa internet can do this in one. Can you do that in one entry?
Ano sir, pagka naka polar form po, kino-convert ko po muna siya sa rectangular kasi yung rectangular form po yung na-compute niya.
Okay. So that's good, no? Pero yun ang maganda sa calculator eh. Pwede mong i-mix yung polar tsaka pwede ka mag-add ng polar to rectangular. And automatic kino-convert na niya sarili niya, no? Anyway, if you convert this back to V of L of t, no? Because remember this is your phasor. So this 30 times the square root of 2 times the square root of 2, that becomes 60. And then this is cosine of 10t, no? Omega is equal to 10 plus 53.13 degrees volts. So yan, example yan ng voltage division. Ito, example to ng, well, madaming solutions ito, no? So, sige. Ano yung first step? Can you remind me? Ano yung first step?
Convert into impedances.
Okay, convert into phasors and impedances, no? Convert. So you transform the network basically. Transform network. Okay, anong magiging value of V ko?
200 over square root of 2 angle 0.
By the way, no? when the angle is at 0, sometimes we call that our reference phasor. Zero angle, no? When the angle is at 0, we call that our reference phasor. Kaya yung naging reference phasor, kasi kung ito yung real part niya, imaginary part niya, asan siya sa phasor diagram? We talked about phasor diagram. A phasor diagram is a snapshot of the phasor at t equal to 0. Ang position niya is here. So this is V. So this is our reference phasor. Okay, but right now don't worry about that term too much, no? Because pag minsan binibigay sa atin yung voltahe just in RMS value, no? And we have to assign a phase angle. Okay, so we assign one quantity to be the reference, and then everything else will be relative to that, no? So this is our reference phasor at an angle 0. Omega is equal to 10. Okay, sabihin natin, I want this to be Z1. Ito gusto ko maging Z1. Ito gusto ko maging Z2. At saka ito gagawin kong Z3. Can somebody tell me what is Z1? Wag na si Aquino, no? Either Mori or Ivan. What is Z1?
6 plus J12 po.
Okay, 6 plus J12. That's right, no? What about Ivan? What is Z2?
Sir, 5 plus J5.
Exactly, no? 5 plus J5. And then J3, ako na lang sasagot dito. This is minus J10. So it's 1 minus J over omega C. Omega is equal to 10 times 0.01. So that's 0.1. So 1 over 0.1 is 10. So minus J10. Okay. So ito ngayon yung transform network ko. Okay. So how do I solve this? No, what I want is I1, I2, and I3. Okay. So this is now my transform network. So this is V. So this is 200 over the square root of 2 at an angle 0 degrees. Sige, lagay ko na lang, no? Z1, Z2, at saka Z3. Okay, so this is V. So this is my phasor I1, this is my phasor I2, and this is my phasor I3. So ang solution na gagawin ko rito is nodal analysis. No? Nodal analysis. So nodal analysis, ito gagawin kong reference ko. And then itong node na to, my node voltage, I will make this, sabihin natin Vx.
Okay na.
So what is my nodal equation? Sige, si Aquino, ano yung nodal equation ko?
I1 Vx po yung ano, di ba?
Oh, Vx. Ang variable ko is Vx.
Vx over 3 over Z3 plus Vx over Z2 minus Vx over Z1.
Medyo sumablay ka ng konti dun sa huli, no?
Minus, di ba papasok ko yung I1?
Vx over Z1? May kulang. Malapit na. Ano yun?
Vx minus V.
Okay, that's right. Vx minus V over
over
Z1
Z1.
equal to 0. Okay? Wag mo kalimutan. Kasi yung node voltage mo dito is V. No? So para mo makuha yung... Actually, yung current na kinukuha natin is opposite I1, di ba? Kasi ang currents natin, we assume palabas dito, at saka palabas dito. So you add all of those three, that's equal to 0. So this is actually opposite of I1. No? Okay? So if I manipulate this, what is this? This is Vx over 1 over Z1 plus 1 over Z2 plus 1 over Z3 is equal to, tapos ilagay ko tong term na to sa right side, V over Z1. No? V over Z1. So anong expression ko for Vx? Vx is just going to be V over Z1 multiplied by 1 over Z1 plus 1 over Z2 plus 1 over Z3 raised to the minus 1. Tama? Nakita nyo?
Yes po, sir.
Okay. So what is Vx? Okay, that's equal to, ano yung V? V is 200 over the square root of 2 at an angle 0. Ang Z1 is 6 plus J12. Okay, this is 1 over 6 plus J12 plus 1 over Z2 is 5 plus J5 plus 1 over minus J10 raised to the minus 1. Okay. Ito yung sinasabi ko. Sa calculator, hindi ko alam sa software na ginagamit ni Ivan, pwede mong pindutin lang yan, lalabas na yung sagot. So, pag-practicean nga ninyong dalawa ni Mori at saka ni Mori at saka ni Aquino. Can you practice with your calculator? Tell me what this comes out to. I'll tell you if it's correct or not.
50 square root of 2 at an angle of negative 36.87.
Ang bilis mo ah.
Sinasolve ko na, sir, habang tinatype mo.
Okay, so this of x is 50 times the square root, ito na naman tayo. 50 times, but you're correct, no? 50 times the square root of 2 at an angle of minus 36.87 degrees. Therefore, I1 is just Vx, it's just V minus Vx over Z1, no? So anong value ng I1? Ang I1 is V minus Vx over Z1. Yung baliktad nga nito, di ba? Okay? I'll just tell you the answer, no? I1 is 7.071 at an angle minus 36.87. Okay? I2, what is I2? Vx over Z2. Okay, this is going to come out 10 at an angle minus 81.87 degrees. No, don't forget your units. I'm guilty. No, lagi lang ilalagay yung units. No, volts, amperes, at saka amperes. And finally, I3 is Vx over Z3. No? Vx divided by Z3, that's I3. And this is 7.071 at an angle 53.13 degrees amperes. So ano magiging I1 of t? Ito, multiply ko ng, what do I multiply this with? Square root
of 2.
That's right, no? So this is 10, because 7.071 times the square root of 2 is about 10. 10 cosine 10t minus 36.87 degrees amperes. And so forth. No? I2 is equal to, ito ngayon, this is 14.14 cosine 10t minus 81.87 degrees amperes. No? And I3, this is again 10 cosine 10t plus 53.13 degrees amperes. Nodal analysis. Okay. Is that the easiest way? Sorry. Well, I don't know. What's another way? Another way, I could have done network simplification. So this is just another way, no? Network simplification. So, anong gagawin ko sa network simplification? Ito yung V. Ito Z1, Z2, Z3. Okay. Kung i-convert ko to ganito, okay, Z equivalent, ang makukompute ko rito is actually I1. Kasi ito yung I1 eh. Right? And what is Z equivalent? Z equivalent is just Z1 plus Z2 in parallel with Z3. No? These two are in parallel in series with Z1, that is equal to Z equivalent. No? So what is Z1? Z1 is 6 plus J12. And then you have Z2 in parallel with Z3. Z2 is 5 plus J5. Z3 is minus J10 over 5 plus J5 minus J10. No? Siguro alam na ni Aquino yung sagot nito. Napindot na niya. Anyway, just to give you the answer, Z equivalent is 16 plus J12. 16 plus J12. So automatically, I1 is V over J equivalent. So that's 220 over the square root of 2 at an angle 0 degrees all over 16 plus J12. And you should get exactly the same answer that we got earlier. No? 7.071 at an angle minus 36.87 degrees amperes. So this should be the same. Okay, if I know I1, how do I get I2? Any suggestions?
KCL?
Current divider, sir.
Yon, no? KCL pwede, except that hindi ganun ka-straightforward kung KCL. No? Ang tool that you right now can use is current divider. So ano yung expression ko for I2? Ituloy mo, Ivan. What is I2?
Wait lang, sir, medyo. Wait lang po, sir.
No problem, no problem.
Ito, sir, I2 po is equal to I1 times Z3 over Z2 plus Z3.
Tama, no? Z3 over Z2 plus Z3. And then also finally, I3, by the way, these are phasors. I3 is equal to I1 multiplied by Z2 over Z2 plus Z3. So dapat yung makuha yung sagot would be the same. So that's network simplification. Okay. Meron pa ba ilang technique? Can you think of another technique? Meron pa ba kayong ibang naiisip? Okay, actually ito naisip ko lang ngayon, ano? What if I converted this to a current source? Okay. If I convert this to a current source, I can solve for I2 and I3 using current division. And then I can solve for I1 by just adding I2 plus I3. Di ba? Pwede yun?
Yes po, sir.
Oh, no? Convert ko to current source. Ano magiging current source equivalent nito? Yung current ko is V over
Zero.
J1. Tapos in parallel with that would be J1. No? Sige, let's just ano lang, no? Let's just show that. Outline lang natin yun. No? Sorry. That's not what I wanted to do. Okay? So, ito, this is V, J1, J2, J3. I can convert this to this, no? Where this is V over J1. Okay? And then now this is J1, J2, and J3. Okay? This is I2. This is I3. Saan ang I1 dyan? Andito yung I1. Okay? Kasi dito tayo nag-convert eh, no? Dito tayo nag-convert, so dito yon, no? Okay. So let me call V over J1. Let me call this I, no? I. Let me call that I. So what is I2? I2 is equal to I. Do you remember the formula? One over J2 all over 1 over J1 plus 1 over J2 plus 1 over J3. Nakalimutan na ba niyo yung formula yan?
Ano yan? Almost yung capacitance, sir.
Ano, no? No, this is current division.
Yung special case lang po yung natandaan.
yung special case ng current division is pag dalawa, di ba? Pero
Yes, sir.
pag madami na siya, the current will divide according to the admittance, no? Kung resistive siya, the current will divide according to the conductance. So dito according to the admittance, no? So anyway, yun yung current division formula, no? I2 is equal to I, and then this is the admittance here, and then this is the total admittance. Okay? Because ito yan eh, no? I2 multiplied by 1 over J2 is actually the voltage across this. And then So, teka. Sorry. I2 divided by 1 over Z2. So kung ito ilagay ko sa ilalim, I2 divided by 1 over Z2 is actually the voltage across this. No? Because that's I2 multiplied by Z2 actually. No? And then I divided by the sum of these admittances. This is the equivalent admittance would be the voltage across it also. Anyway, yun lang yung formula mo. No? So this is just current division. Ganun din, no? Yung I3 is equal to I, 1 over Z3, all over 1 over Z1 plus 1 over Z2 plus 1 over Z3. Okay. And then I1 is equal to I2 plus I3. So that's another technique. No? Okay. Sige. I don't think we have to go further, no? I think na ano na naman no? Na nagigets na naman ninyo yung technique, no? Simple lang naman yung steps. You transform the circuit, then you solve for the quantity that you're interested in, and then you do the reverse transformation. Dito sa exercise 4, okay, you have two sources. You have two sources, this and this. Okay, so you have to do your transform circuit. Ano yung transform circuit natin? Ang V's of S ko is 100 over the square root of 2 at an angle 0 degrees volts. My I's of S is equal to 10 over the square root of 2 at an angle of 30 degrees amperes. Okay, let me call this Z1. Okay, Z1 is equal to 5 plus J5 ohms. No? Ito, tawagan ko na itong ZR. ZR is equal to 10 ohms. And then let me just call this Z's of C. Z's of C is equal to minus J10. Okay. So if I do nodal analysis, so this is V's of S, Z1, ZR, ZC, I's of S. Ang problema ko is getting IX, no? So this is IX. So lahat nito magiging phasor. Nodal analysis. So sabihin natin this is my unknown. Call this V of X. Okay, ano yung nodal equation ko? Si Mori, tanong ko, what is my nodal equation?
So sir, Vx minus Vs over Z1.
Over Z1.
Tapos plus Vx over ZR.
Okay.
Plus Vx over ZC.
Okay.
Tapos plus Is.
Plus?
Is po.
Plus or minus?
Minus pala, sorry.
Minus Is is equal to 0. Okay? So ang unknown mo lang dito is Vx. Vx is the only unknown. So I can solve for Vx. Solve for Vx. How do I get Ix? Simple na lang, di ba? Ix is just now Vx over ZR. So solve na rin yan. So that's using nodal analysis. Remember yung go-to solution natin almost always appears to be nodal analysis. Pag di na natin alam kung anong gagawin, usually nodal analysis na lang, no? Nodal analysis na lang yung ginagamit natin. But there are other solutions. You can do this using superposition. Ano yung pag superposition, anong gagawin natin? Okay, you compute for Ix taking one source at a time, no? Kasi ang superposition, the sum of your total response is the sum of the individual responses of each independent source taken by itself. So you have two independent sources here, Vs and Is. So una, Vs acting by itself, so open circuit to. Pangalawa, Is acting by itself, so short circuit ito. Each time computing for Is. So after doing that, then you just get the total Ix, no, not Is, Ix. So you can do that using superposition. You can also do that using Thevenin's theorem. Thevenin's theorem, tatanggalin natin tong Z's of R. Kukunin natin yung Thevenin equivalent of the circuit with respect to the terminals of Z's of R. Thevenin equivalent is your open circuit voltage. So how do you take your open circuit voltage? Again, siguro nodal analysis, no? Nodal analysis siguro pwedeng gamitin. And then how do you get your Thevenin impedance? You short your voltage sources, you open your current sources, and you get the impedance looking into the terminals of ZR. So that will end up being Z1 just in parallel with Z of C. So that's a Thevenin's theorem. So gawin na lang ninyo, no? I'll leave that as an exercise for you to do. Like I said, I won't have anything more to lecture to you on Thursday. Actually, ito nga, this is a repeat of what I lectured last week. But I will still go online if you have any questions with respect to any of the examples that were presented either in UVLE, yung official course material, or dito, no, kung gusto nyong check-in kung tama yung mga sagot ninyo, I can give you the answers on Thursday. Okay? Are there any questions?
Sir, may tanong lang po. Hanggang kailan pa? Hanggang ilang lesson na lang po tong 1, 2, 3? Tatlo po ba? Dalawa?
Pagkatapos nito, no? Next week, ang topic ninyo is power calculations. So ganun din, no? Mga AC circuits, pero now calculating power. And you're going to find that power sa AC circuits, ganun din, may real power and may quote-unquote imaginary power. No? There's something like that, no? So power calculations, that's next week. And then after that is 1 week, you'll take up transformers. Tapos na yung course.
Sige, thank you po, sir. Thank you po.
So malapit na.
Lapit na.
Tapos yung pagdurusa. So malapit na rin yung exam.
Lapit na bumagsak, sir. Joke lang.
Hindi kayo babagsak. I mean, I think you're basically people are doing okay, no? Any other questions?
So sir, clarify ko lang, yung phasers po na topic, good for siya for 2 weeks.
Kasi yung next week na kukunin nyo, gagamitin pa rin yung phasers eh. And actually kahit sa transformers, gagamitin nyo pa rin yung phasers. Ang phasers ginagamit yan for alternating current circuits, ano? Anything that has to do with AC, ang usual tool na ginagamit natin is phasor analysis. And transformers will only work with AC. No? At least yung transformers na pag-aaralan ninyo, These are yung mga distribution transformers, yung mga step up, step down, yung mga ginagamit ni Meralco o ginagamit niyo sa bahay 110 to 220. Yun yung mga transformers na pag-aaralan ninyo, no? Those are all AC. Those only work with AC. So actually, itong phasors, yung last 4 topics is actually all requiring phasor analysis.
Pero sir, for this week po ba may ano pa rin, may problem set and quiz since pareha lang po yung last week and for this
Meron
week.
pa rin, meron pa rin.
Meron pa rin. Sige
Oo.
po. Pero po ngayon pang pag-a-analyze po ng AC circuit.
Kasi pag tinignan niyo yung dinistribute na material for this week, talagang puro examples lang eh. Pero makakatikim kayo ng iba't ibang klase mga examples. So tignan niyo yung ano no, yung release, yung 11, module 11. So you'll see that it's all examples. I think, no, I recall it's all examples. So all of the theory was presented last week, and then now it's really all application. Okay, any other questions? Sige, kung wala nang tanong, then the rest of you can sign off. And then I will entertain yung question ni si Ivan ba? Ang may question tungkol sa quiz?
Yes, sir.
Okay.
Thank you po sir.
Okay.
Thank you, sir.
Okay.